You understand what we're doing here? So we've got there's no other way. The other way is just go to the end and use the formulas as they're derived by doing that in general for any function. So if you're getting stuck and you can't pierce through that map, that's fine. You can just use the final equations. It doesn't matter. So the homogeneous, I'll write it here so in case you want to review it later too. So this is y double prime minus 2y prime plus y equals 0. So characteristic equation for this is the homogeneous part, minus 2y plus 1 equals 0. We can factor through this. R minus 1 equals 0. So we have R equals 1 repeating. R equals 1 repeating. And now we can take this and find the complementary solution, which is C1 e to the minus x, or x, plus C2 x e to the x, since this is a repeating root. And so now we will assume y particular of the form u1 e to the x plus u2 x e to the x. I will derive it here then for you as you're working, and then you can review it later and see too, like if you didn't figure it out, or if you decided not to do it, how to go about it. And if you're stuck somewhere too, you could see me do it if you want, and then learn it. So we assumed y particular of that formula. And now what you do is you find y prime. So I'm going to use the product rule here. So u1 prime e to the x plus u1 e to the x. And then here we will use the product rule on these two. So plus the first one is u2 prime times the second as is x e to the x plus the first as is times the derivative of the second, which is in of itself a product rule. So the derivative of x is 1 times e to the x plus the first times the derivative of the second, which is e to the x. Now, here comes the trick that we were talking about, is because we're going to impose a constraint that's, you can call it Lagrangian constraint, is we're going to say that these two add up to 0. Okay, which means I can knock them out of the equation, and I'll come back to this equation later. So this is equation 1. You chose two functions, so you can impose one constraint of your choice on the derivation, and then the second one will come from the actual differential equation. So now my y particular is just, or my y prime is without these two red ones, the red boxes. So it's u1 e to the x plus u2 e to the x plus u2 x e to the x. Now here you find y double prime. So derivative of this is u prime e to the x, u prime 2, so u2 e to the x plus u2 times the derivative plus x equation plus the derivative of the first, which is u2 prime x e to the x. So let's see if we have any like terms here. Not really, except for one. So y double prime equals u prime 1 e to the x, and we have u1 e to the x, and we have u prime 2 e to the x, and u2 e to the x, because there's two of them, and then we have u2x e to the x, right? And then the last one, which is u prime 2 x e to the x. And now we're going to plug that into the original. So y double prime, which is this whole thing. So let's put this up. So starts with u prime 1 e to the x plus u1 e to the x plus u prime 2 e to the x plus 2u2 e to the x plus u2x e to the x plus u prime 2x e to the x minus 2y prime, so minus 2 times what's remaining from this one without the ones in the red boxes, because we said those are 0. So we get u1 e to the x, so minus 2 times u1 e to the x plus u2 e to the x, right there, plus u2x e to the x plus y, yeah? Y is the very original one, so u1 e to the x plus u2x e to the x, and we will set this equal the non-homogeneous term e to the x root x. Okay, so let's collect the like terms here. So we have the first one, there's only one, so that's just u prime 1 e to the x, and then we have u1 e to the x, and we have here minus 2u1 e to the x, so that's minus u1 e to the x plus u1 e to the x, so those go away. And then we have u prime 2 e to the x, the only one, so done with this one too. Put it here, u prime 2 e to the x, and then we have 2u2 e to the x, and we have negative 2u2 e to the x, so those two go away, and then we have u2 x e to the x, and then we have u2x e to the x and another u2x e to the x, this was so u prime 2x e to the x, and then we did u2 e to the x, So 2 minus 2. No, these completely go away. 2 minus 2. Okay, and then we get u2 minus 2. So 1 minus 2 u2 x e to the x, so minus 1 x e to the x. And u2 x e to the x, oh yeah, so those all go away. This, and this. And then we've got left with u prime 2 x e to the x, and that's equal e to the x root x. So if we factor out, so we can just knock out e to the x from all of them. So we get u prime 1 plus, I will factor 1 plus x from these two, u prime 2 equals root x. So this here is my second equation. Equation number 2 that I'm trying to get. And equation number 1 was u prime 1. So I'll just move here equation number 2 down here. U prime 1 e to the x. I will also knock out e to the x because this is never 0. So u prime 1 plus u prime 2. So u prime 1 plus x u prime 2 equals 0. So this was equation 1. And now we can subtract the two equations. And looks like we're going to get something promising and simple here. So if I subtract, these two go away, and I get u prime 2 plus x u prime 2 minus x u prime 2. Bingo. So those two go away. Equals root x. Turns out u prime 2 is just root x, which is very simple. So now this is the same thing as saying du2 over dx equals the root x. Separate the variables, the very first section of the class where we separate the variables and integrate, no? So du2 will be root x dx, and then I can just separate, integrate both sides. So we will get u2 to equal 3, so it's x to the half, so x to the 3 halves multiplied by 2/3. So this is our u2, right? And we already know that u prime 1 is just from equation number 2, the simplest one, or equation number 1, 2 here underneath the labeled number 1. U prime 1 is just minus x u prime 2. So u prime 1 is minus x. U prime 2 is just root x. So that makes u prime 1 minus x to the 3 halves. So now we just have to do the same thing. So this means du1 over dx equals minus x to the 3 halves. No? Multiply the dx on the right hand side. So we get du1 equals minus x to the 3 halves dx. And now all we have to do is what? Integrate both sides. And so we will get u1 to equal, this is a little bit light here, let's choose another color. How about this? U prime 1, oops, this is too bright. Yeah. How about this? Where are you choosing? Let's do that. u prime 1 equal minus the integral of x to the minus to the 3/2 will be, add 1, you get 5/2 and you multiply by 2/5. Right? There we go. So we've got our u prime 1 and we've got our u prime 2. Therefore, y particular is just u1, which is minus 2/5 x to the 5/2 times, if you remember, our original assumption e to the x times e to the x plus u2, which is 2/3 x to the 3/2 we got it here, right, to the 3/2 times x e to the x. Bingo. This is the particular solution. Which one are you working on then? You get the idea here?